Okay. So maybe we're probably okay to good to start. Okay. All right, so we can get going. So Conrad just wanted me to go through the crash course file, which is a big Mathematica notebook that she's already put together that has a bunch of just kind of an introductory like steps of what most people will be doing in their Mathematica projects, which I'm sure is where you'll see it most in MATLAB. And then just some common student errors. And so the link to that file is if you go to the schedule for MATLAB and CS Lab, it's on the MMA helps tab on that very bottom. You can scroll and find it. So I'll give you guys a chance to pull that up. And then I think it will ask you to log in with your Bethel username and password. And then you should be able to see from there. And then once you get to this screen, you want to click on the MMA crash course 1920. And then the one that's not worked out. Ruth, this Mathematica notebook is not popping up over here. Let's see if we can. Okay, sorry guys. Trying to figure out how to get this to come up on the projector.
It should just, is it on your screen?
Yeah, but it's like a dual. There we go.
Is that screen shared with the?
Yes, yeah, this one is showing. Okay, so does everyone have the file up? Okay, cool. And then what are people's experience with Mathematica? Have you used it before? Okay, so you know the basics of like how to evaluate a cell, how to define functions, that kind of thing. Okay, so a lot of this we can kind of just breeze through then, and it probably won't take the full 45 minutes. So this is just a video that we won't watch, but if you wanted to go through in your own time, you're more than welcome to. But if you guys have some experience with it, it probably wouldn't be that much new information. So we'll scroll down to, it talks about opening and saving files. But again, if you guys have some experience with it, I trust that you know how to open and save them. And just make sure to remind students too to save frequently, because if Mathematica crashes, that would be really unfortunate if they lose or if they lost their progress. And I haven't seen this issue in MATLAB, but if people are naming their Mathematica notebook in a way that doesn't recognize, like if they have different, like if they have more periods in there, or if they even have spaces, Mathematica might have issues with that. But it should give you an error message if that was to happen. But we can keep scrolling down to cells and formats. Again, this is probably not new information for you guys, but you guys can expand cells. So sometimes if students are missing that in a project, they might not know that there's more text in their template if it's given to them by a professor. Evaluating you guys know how to do that, Shift Enter. I guess I probably should have asked that for people on Zoom. Is anyone brand new to Mathematica? Okay, I'm gonna take that as a no. Okay, so we'll skip over that. Should have lost my mouse. Okay. Creating cells, just right when that your cursor turns horizontal, that's when you can add a cell in there and you can do your other style or text, or if you just start typing, that's going to be like your standard input form that you can evaluate. And formatting cells, that's exactly what I just showed you. So it's these guys, but you can also highlight a cell. So you can click your bracket here, and then if you do a right click, you can convert it. So this is one thing where it sometimes, I haven't seen people use traditional form, but you want to make sure that it's in standard form. I think that will come up earlier, but you can also change the style, which will, you can change it to text, title. So that's more of just like an organizational thing than anything else. Okay. So those are just some shortcuts that you guys are interested in. Here, some people, I have noticed students will just start typing because they don't know that you can type in text. And then if they try evaluating their whole notebook, some weird things will happen. So if you guys evaluate that cell on your computers, you'll see that it looks like you wouldn't want that to happen. It is weird, but that's because it's trying to evaluate text as some function. Okay. So we will keep going. Shortcuts, you can either use those, or you can do that right click thing and change the style. Copy, pasting, and deleting cells. It's still your typical shortcuts that everyone's used to. Or you can just, if you highlight it to delete it, you can also just highlight that right side and then just click delete, or your backspace key, depending on what type of computer you have. And then this was the traditional form here. So I guess I've never run into this, but just stick to standard form. The notation is a little bit different. But then again, to change that, just go here. And then if you convert it to standard form, there we go. It will change it back to what you're typically used to seeing, and then you can evaluate it like normal. Style sheets are something that I guess I'm also not super familiar with, and I haven't seen in math lab. So I'm gonna kind of just skip over that section, but if you're interested in it, there's some other documents that you can look through and dig through in the math department file or drive. Okay, so we're gonna kind of move on from that, but palettes are a big thing. Palettes are pretty easy. If I can not see the Zoom menu. It's like way up at the top. But anyways, in the normal Mathematica, you should be able to go to, let's see if I can get my mouse back. I want to be able to see it at the top. Is it palettes and then your menu up at the very top? Palettes and then basic math assistant. Yeah. Okay. It's hard when I have the dual monitors, but if you go to palettes, basic math assistant, that will give you access to pretty much doing anything like you can have your square roots or cubed roots, whatever you're looking for. You can get to the different characters, so like e or pi. And then you also have some integrals. You have like your subscripts, your fractions, things that make it easy. And so then from there, you guys can do shift enter and evaluate it along the way if you want, but just simple things like that. You can do indefinite integrals or definite integrals. I think there's both on there. So you guys can experiment with that if you want, but we can kind of just keep moving through it. And then I know for projects, especially the Calc 2 projects, they'll have their Riemann sums, so kind of like their Introduction to Integrals project, which I think has already happened for this. Yeah, okay, I'm getting some nods. So that's already done, but I think they have another like differential equations project, and I don't think they have a palette for that one, but some profs will give them a palette that they can download and then install, so then they don't have to keep on typing all their sigmas and all of that. So just be aware and maybe just ask the student, hey, did your prof give you this? Because that might be really helpful and save some time. But then there's some instructions to install the palette there, which I think if you just have to download it from Moodle or wherever they give it to you, and then you install it from Mathematica.
There's more instructions at the bottom. Too.
At the
For
bottom.
installing palettes, yeah.
Okay, perfect. And then in terms of creating constants, I'm guessing since there's some familiarity with Mathematica already, you guys know how to do this. But that you can give it a variable name and then just equals and then whatever your number is. And then it will remember that. So you can evaluate it. And then if you want to clear it, it's just clear and then square brackets and then my constant. So then if you were to evaluate this again, it's not tied to a number anymore. So you guys can create your own constant if you want. And then suppressing outputs, I'm guessing you guys are also familiar with this then, where here, if you evaluate it, it's going to spit out the constant that you defined it as, and then also whatever you're wanting to evaluate. But if you use a semicolon, it's going to hide that what you're defining your constant as, and it's just going to spit out the squared value. So that can be nice and a good reminder for students, especially if they have a lot of stuff in cells and they're defining a lot of functions. It will be a lot neater and safe space if they're using semicolons. And in another thing about clearing variables, a lot of times too, if students are always using X or A or B or whatever they're using, and they're not clearing it before things, sometimes that can carry down into other sections of their notebook. So it's always just good practice to, if you're moving on to a new problem, just clear it at the end of the one beforehand. And then it's not something that you have to worry about. So then special constants. So for pi, e, or even your imaginary numbers, so for I, again, you can use the palettes for that, or you can use, if you write pi, use a capital P, use a capital E or a capital I. But then you also want to make sure that you're not using that in other functions because they are like special constants in Mathematica that it's always going to recognize as. Our door? Oh, okay, right, sorry. So then there's also a couple shortcuts where you can use your escape key to get those three constants, but you can kind of just use whatever method you're most comfortable with. And then some typesetting shortcuts. So those are some more shortcuts for your superscripts, subscripts, even your square root. I like to use the palettes a lot. That's just what I'm most comfortable with. But if you can remember those and those are easier for you, they're also there. And then for some numerical approximations, Mathematica is always going to try and keep things as exact as possible. So if you were to evaluate that, it's going to not give you something in a decimal form. It's going to leave it in terms of the constants. So if you wanted to find the numerical form of that, you would have to do an n and then square brackets and then your function inside. And that way it will spit out a decimal value for you. And if you wanted more decimal places, what you can do is you can put a comma afterwards and then you can say 20 and it's going to give you, it will give you 20 decimal places then. And I know that at least Professor Conrath or Dr. Yang, whoever's teaching Calc 2 they've used that and that's come up. So then if you wanted to do pi to 100 decimal places, what you would do is just n square bracket pi comma 100. And then you can get the first 100 decimal places of pi, which is quite a few. So then kind of going off of they're always going to try and keep things as exact as possible. It's good to also write your functions in terms of that. So if you don't have to write it into, you don't have to do like 2.0 versus just 2. So that one will still give you 2 pi, but that will spit out a decimal value. But it will probably be easier for the grader, whoever is using the key, if you're keeping things most exact, because it will probably also be in that form rather than with a decimal. So then, yeah, just use fractions rather than decimals and things like that. So functions, all of your functions will start with a capital letter, and then they all use square brackets whenever you're putting in an argument. So a lot of times where I see this issue is if they're using like trig functions, so like sine and cosine, they're either not using a capital S or a capital C, or they're just using parentheses and they're not using square brackets. So then, yep, arguments for functions are enclosed with square brackets. Parentheses are what you normally use them for when you're writing with a pencil and paper, and are used to show groupings. And then curly brackets are for lists. And so you'll see a lot of that with like graphing when you're typing in your ranges for where you want things to be plotted on. Then in terms of creating functions, a lot of students will either miss the underscore or they'll just do an equal sign and they'll miss that colon. But it will always be your function name, square bracket, and then you can give the list of your input arguments. So in this case, it's just x. So then x underscore, close your bracket, and then colon equals, and then whatever your function is. And so then if you wanted to use that function again, just remember to use square brackets, and then you can evaluate that wherever you want. And it will give you that output. So then here you can see different functions that you can create. They can be words, they can be just a single letter. But we'll keep moving from there. So then again, clearing variables and functions. Here you can, oh, that all looks like it's one cell. There it goes. So you can define a bunch of constants and a function within one cell, and then you can see that it's evaluated that, but then you can also clear, just like you clear variables, you can also clear the function, and all you have to do is just type in the function name. So then you guys should be good. And another way to tell if it's been cleared or if it's the variable or function has something saved to it is the color of the text. So if there's nothing saved to it, it's going to be blue, but as soon as you define it, it will turn black. So if we go back up here, see how all the variable names turn black. And then even down here, Mathematica recognizes them as some value. So then if you clear them, they turn blue again, which is just kind of a good mental check. So moving on to plotting, you can define your function and then you can ask it just to plot that function. You can also just type, you could also just have like 4x cubed minus x plus 3 in place of f of x there too. And then in the next comment or a next argument, I guess is what you would call it, you can do curly brackets. And so then here you're asking it to plot it from -2 to 2. So if we evaluate that, there it goes ahead and plots that from -2 to 2. And it's just giving a default range. If you wanted to give it a range, you could either type, I think it's down here farther. Maybe I'm getting ahead of myself. Yep, plot range. So from here, you would be plotting f of x, and your x would be going from 0 to 1, and then your y-axis would be going from 0 to 6. So if you did that, there you go, 0 to 1, 0 to 6. And you can also plot multiple functions. I'm sorry, I'm kind of jumping around here. And you can just type those in a list. So then it will be your plot, you'll have your opening and closing square brackets. But then if you're plotting multiple functions, then you'll need to do a curly bracket, give that list of functions, and then close that curly bracket. And then you can go ahead and give the range. And tooltip, I haven't seen many students use this, but all it's doing is just if you hover over a line. So I think here, if we can show an example. You hover over a line, it will show you what the function is. So we'll just do something simple. We'll just do x. So we'll say that. So here, then that's just plotting it. And then if we go to tooltip, then if you hover over it, it will give you x. And here it will give you our function earlier that was defined as f of x. Okay, so we did plot range. So now finding derivatives, there's a couple different ways that you can do it. The first one is just using apostrophes. So here you can define f of x, and then if you're just using apostrophes, there's the outputs. You'll get what you expect of 1 plus 2x, and then your second derivative would just be 2. And if you're not getting something that you expect, again, just go ahead and clear that variable that you're using, and then try reevaluating it. And then the second method is just to do a capital D as the function command. And then what you can do is you can give the function, and then the next list that you'll give is, it'll be a curly bracket, and then the variable that you want to take that derivative with respect to, and then what derivative you want to take. So this one, you're asking it to take the first derivative in respect to x, and that second line is asking you to take that second derivative. So then you should be we get the same answers. And if you're just taking the first derivative, you don't need to have the curly brackets and that comma 1. You can just go ahead and just do comma x, and it will do the same thing. So do you guys feel kind of comfortable with those commands? Yeah, okay. Nice. So we'll keep going. So integrals, you have definite integrals and your indefinite integrals. So I use the palette most of the time, but you can also just type integrate, and then you can give your function, and then again, what you're wanting to integrate in respect to, and then you can give your upper and lower bounds. And either way will give you the same answer. And then indefinite integrals, it's the same thing, except you just don't have that last argument that gives you the bounds. And then obviously, if you're using the palette, you don't have to put the bounds there. The only thing with this one is just be careful that it doesn't have the plus c at the end. So just remind students that, hey, you have an integration constant that you don't want to forget about. Yep, and so that's what this warning is all about. So yeah, Mathematica also doesn't include the absolute value bars. So just kind of do a mental check. Does my answer make sense whenever you're doing integrals, or really any function? So sometimes when you have complicated trig functions, you'll get some interesting outputs that aren't as clear. If I got that output, I wouldn't know what to do with it. So it's just easier if you use the n integrate, which will just give you a numerical value right away. And won't give you that complicated output. And most of the time, people will be doing definite integrals, they're not going to have an indefinite integral of cosine x squared. So if you're doing that, it will just spit out the number that you're looking for and won't give you that complicated output. And so that one's even has an imaginary component. So then in terms of solving equations, so there's a couple different things that you can try in the order that you want to try them in. So first you can use the solve command. That's going to give you the most exact answer. But then sometimes it doesn't work. So then you can go on and try nsolve and see if that gives you a numerical answer. And you can also use find root as well. But you just have to then give it an input that says, okay, look for some solution that's around this point. So solve, all it is exactly what it is, or exactly like just type solve with, make sure you have a capital S, your square brackets, and then type in your function, but make sure that you're using 2 equal signs, not just one. So some students might miss that. And then what variable you're solving for. And then it will go ahead and tell you what x equals. So then if you're using nsolve, you hopefully will get the exact same answer. But most of the time students don't have issues with those functions. If anything, they just forget that second equal sign. So then in terms of find root, here you're telling it, okay, we're going to solve for x, and then look for a root or a solution that's near 1. And so it's going to give you 2. So then you just have to know -2 is still a solution, and just be aware that it might not give you that full solution. Okay. So this example, it's wanting you to find the minimum of the function sine of cosine of x near 3. So if we plot it, this is what it looks like. So it looks like we have a minimum there. So it wants us to, well, first define our function. And then we can see, we'll first try solve if it can find when the derivative is equal to 0. So there it did give us an answer. So you might not know what arc cosine of pi over 2 is off the top of your head. So that's an easy problem to fix of just evaluating that numerically, and you can, but then we run into yeah, we know that it's not a complex answer. So then, let's see what happens now. Well, I'd like to get an answer. That's not complex. Okay, so nsolve, we still run into that same issue, is we're getting 0 and then that imaginary component, but we don't want that one. So then last resort is the find root, and then it is able to solve for that. So it looks like it's at pi. And that's exactly what we want to see. Cool. So limits and sums, another common functions that people will have, especially in the calcs. And so limit is its own command, and you can type in your function and then just say, okay, as the variable x or whatever you're looking to, and then you can use that arrow, which I know is in the palette, and your infinity signs are also in the palette as well. So you can either do it that way, and then you can also find sums. And again, palette's probably the easiest place to find those. And so it will spit out those limits for you. Okay, and then have you guys heard about the kernel? Okay, a couple nods. So the kernel is basically Mathematica's brain, essentially, or where everything's being stored. And so when you quit Mathematica and then you open it again, it's not going to remember all the variables that you had evaluated. So you might have to reevaluate things again. So you can evaluate a whole notebook if you go to evaluation at the very top of your menu. And then you should just be able, there should be a, evaluate and then evaluate notebook. You can click on that and then it will run through that whole notebook on its own. But then another thing to note is that if you have multiple Mathematica notebooks open at the same time, and you have x equals 2 in one and x equals 3 in another, whatever one you evaluated last is what x is going to equal in both of those notebooks, because the kernel is shared between different documents that are open. And so one thing, my kind of fail safe, if something's really not working and I have no idea why, I just have them quit the kernel and then we reevaluate things, and sometimes that just fixes the problem. And that's another thing to look at, and you can do that by going back up to evaluation, and then there's an option that just says quit kernel, and then it will bring you a pop-up menu that's saying, are you sure you want to do this? And then just click yes. And then another thing too is if a cell is taking a really long time to evaluate it, you can stop that by just going to evaluation and then abort evaluation, and it will just cancel that, and then you can look and see where the mistake is so that it's not taking forever. And then common errors and problems. You can use an asterisk as a multiplication, or you can just use a space. But if you're like this example is x times y, if you just have x, y, and you don't have that asterisk or you don't have a space, it's going to look for a variable that's named x, y. So that's just a common thing that happens. Or if people don't have their variables that match, or sometimes functions and variables are all messed up again. So that's like, okay, just quit the kernel, clear some variables if you're using the same one consistently throughout a notebook. Remind them to save. A lot of times you'll see like brackets they have those mixed up. They're either using curly brackets or parentheses when they shouldn't be, and they should be using square brackets. Their integrals. Let's see, what is it? I haven't had too many issues with integrals, but yeah, you can just make sure that you are, yeah, sometimes you can use parentheses to make sure that it's catching that whole thing, if that's not working, but usually that isn't too much of an issue. Sometimes printing can be a pain, but if you're running into that, you can direct the student to this file, or you can pull it up and work through it with them. It's in the Math CS department's drive. And then corrupted notebooks. So if you're saving and if you're saving your file and you're clearing variables, then you shouldn't have too much of an issue. And I haven't run into this yet. I don't know if you guys have run into corrupted files. Okay. So then you should be good. I would say brackets and then just variable names being slightly different too. Or if they're using words and then they don't spell their variable the same, that also can be just a small mistake. So those are the things that I've run into. I don't know if you guys have run into other issues that you didn't know how to solve, but that is basically all this has. And these are just some other resources. I know Google is also just a good place. Like Wolfram Alpha has a lot of help there and good tips if you're getting stuck and don't remember the name of a command for something or what the inputs of that command needs. So that and dynamic updating, I haven't had any issues with. If you get an error message, usually it will tell you what you're missing. So like here, you're missing that curly bracket there. And then you should be able to evaluate it. But before you even evaluate it, you can tell that there's an issue because your brackets are colored. So something is not being closed or your bracket off, which is helpful when you have a lot of parentheses happening and things like that to make sure you have everything closed. And then those are just some advanced topics that are talking about plots. But I think are you guys pretty comfortable with plotting? And do you know how to do contour plots and 3D plots? Okay, I got some nods. So then you guys should be good. Yeah, you can just have multiple arguments if you have multiple variables. Contour plots are the exact same way. And in matrices, one thing that I've noticed is if you're doing a dot product, make sure to use a period instead of an asterisk. But you can define your vectors matrices either as a list with curly brackets, or there's a place in the palettes too where you can do that. And if you want it in matrix form, all you have to do is type matrix form square brackets with your vector matrix inside of it. So those aren't too bad. But yeah, there's where it talks about the dot product. You obviously want to have a scalar value as your dot product, so getting the list out isn't the most helpful. But there's that. And then there's more information about installing the palettes if you need that as well. So that's all I have for you guys. If you guys had other questions. Cool. Awesome. Well, then you guys are good to go. Thanks for coming.
Thank you, Grace.
Bye, Jack.
Bye-bye.